Assalamualaikum everyone. So today we are going to explain about the topic of vector space. So vectors is actually a mathematical objects characterized by two key properties, which is magnitude, length and also direction. For examples, vectors include physical quantities like velocity and also force. In contrast, scalars have only magnitude without direction, such as temperature, time and also length. In the linear algebra learning, we all know that vector space is a set of vectors that is closed under two operations, which is addition and also scalar multiplication. These vectors can be represented as arrows or more abstractly as functions, matrices or even polynomials. A valid vector space must satisfy specific rules such as associativity and include a zero vectors and additive inverses. Scalars used in operation usually come from real number or complex number. Vector space are fundamentals in solving linear system and also exploring more deeper concepts like basis, dimension and also linear transformation.
The purpose of study, first, to explore the concept of vector space in linear algebra in a more meaningful and relatable way, to apply basic vectors operations like vector addition, component form representations, magnitude, and directions, to demonstrate how vectors can represent real-life movements such as walking from one place to another, to encourage deeper interest and appreciations of linear algebra by making the topic feel practical, not just theoretical. Through this topic, we aim to not only fulfill the learning outcomes of our course but also build confidence in handling abstract mathematical structures.
So for methodology, firstly we have to identify direction and represent movement as vector. Define as the positive x direction and not as the positive y direction. Represent each part of the student's journey, house to cafe and cafe to library, as vector in component form. Second, we have to calculate the total displacement. Add the vector representing each movement to find the overall displacement from the house to the library. Next, determine the magnitude of displacement using the Pythagoras theorem to calculate the straight line distance magnitude of the total displacement vector. And lastly, we can find the return path from cafe to house, which is we reverse the direction of the vector from the house to cafe to find the vector from cafe back to home. And then we determine both the direction and magnitude of this return path.
A student walks from her house to the library. She first walks 2 kilometers east and 1 kilometer north to get to a cafe. Then, she walks from the cafe to the library, which is 3 kilometers east and 4 kilometers north from the cafe. Question A. Represent both movements as vectors v and w in component form. So for v, it's the distance from house to cafe. V equals to 2 kilometer to east and 1 kilometer to north. For W, it is from cafe to the library, 3 kilometer to east and 4 kilometer to north.
Let's now move on to the question B. Find the total displacement from her house to the library. As we know, vector V is 2, 1 and vector W is 3, 4. So we need to do the addition method and then we will get 5, 5.
So, for the next question is question C. How far is the library from her house? So, from the part B, we found that the displacement vector from her house to the library is 5, 5. So, to find how far the magnitude, we can substitute all the value into the formula, which is square root of 5 squared plus 5 squared, which will we get equals to square root of 50, and the final answer is 7.07 kilometers.
So for question 4, If the student walks directly from the cafe back to the house, she will go 2 km west and 1 km south, which is the opposite of the original path to the cafe. We can write this movement as the vector -2 and -1. To find how far she would walk, we calculate the distance using the formula square root of x squared plus y squared, which is 2 squared plus 1 squared, which gives us square root of 5, or about 2.24 km. So she would walk around 2.24 km in the southwest direction to return home.
The conclusion is, this activity shows how vector operations like addition, magnitude, and direction apply to practical navigation problems. Understanding vector representation helps solve problems involving movement, force, and positioning efficiently.
So it's end of the video.
Thank you for listening.
Don't forget to subscribe,
Like and share.